Disease is induced by mutation. Sickle cell anemia. Sickle cell anemia is an autosomal recessive genetic blood disorder characterized by abnormal, rigid, sickle-shaped red blood cells. Sickle shape decreases the cell flexibility due to which they can also get stuck more easily in small blood vessels and break into pieces that interrupt healthy blood flow. Signs and symptoms. Signs and symptoms of sickle cell disease usually begin in early childhood. Characteristic features of this disorder include a low number of red blood cells, anemia, repeated infections, and periodic episodes of pain. Anemia can cause shortness of breath, fatigue, and delayed growth and development in children. The rapid breakdown of red blood cells may also cause yellowing of eyes and skin, which are signs of jaundice. Almost all patients with sickle cell anemia have painful episodes called crises, which can last from hours to days. These crises can affect the bones of the back, the lung bones, and the chest. Cause and risk factor. Sickle cell anemia is caused by recessive allele HBS, which encode defective B globin chain. As a result, abnormal hemoglobin is formed called hemoglobin, as HBS is originated from HbA normal hemoglobin gene. Due to a point mutation, the patient inherits two such alleles from both parents. The parents of an individual with an autosomal recessive condition each carry one copy of the mutated gene, but they typically do not show signs and symptoms of the condition. Sickle cell disease is much more common in people of African and Mediterranean descent. It is also seen in people from South and Central America, in Caribbean and the Middle East. Treatment. The goal of treatment is to manage and control symptoms and to limit the number of crises. Folic acid supplements should be taken. Folic acid is needed to make red blood cells. Treatment for sickle cell crisis include blood transfusion may also be given regularly to prevent stroke. Pain medicine, plenty of fluids. Other treatment for sickle cell anemia may include hydroxyurea, hydria, a medicine that may help reduce the number of pain episodes, including chest pain and difficulty breathing, and some people antibiotics to prevent bacterial infections, which are common in children with sickle cell disease. Phenylketonuria. Phenylketonuria is a rare condition in which baby is born without the ability to properly break down an amino acid called phenylalanine. Causes, incidence, and risk factors. Phenylketonuria is inherited, which means it is passed down through families. Both parents and must, both parents must pass on the defective gene in order for a baby to have the condition. This is called an autosomal recessive trait. Babies with PKU are missing an enzyme called phenylalanine hydroxylase, which is needed to break down an essential amino acid called phenylalanine. The substrate is found in food that contain protein. Without the enzyme, levels of phenylalanine and two closely related substances build up in the body. These substances are harmful to the central nervous system and cause brain damage. Symptoms: phenylalanine plays a role in the body the production of melanin, the pigment responsible for skin and hair color. Therefore, infants with the condition often have lighter skin, hair, and eyes than brothers or sisters without the disease. Other symptoms may include delayed mental and social skills, head size significantly below normal, hyperactivity, jerking movements of the arms or legs, mental retardation, skin rashes, tremors, and unusual positioning of hands. If the condition is untreated, or foods containing phenylalanine are not avoided, a mousy or musty odor may be detected on the breath and skin and in urine. The unusual odor is due to build-up of phenylalanine substances in the body. Treatment: this disease is treatable. Treatment involves a diet that is extremely low in phenylalanine, particularly when the child is growing. The diet must be strictly followed. Phenylalanine occurs in significant amounts in milk, eggs, and other common foods. The artificial sweetener, Nutrasweets aspartame, also contains phenylalanine. Any products containing aspartame should be avoided. A special infant formula called Lufenaloc is made for infants with PKU. It can be used throughout life as a protein source that is extremely low in phenylalanine and balanced for remaining essential amino acids. Down syndrome. Down syndrome, also called trisomy 21, is a chromosomal condition characterized by the presence of an ultra copy of 21st chromosome either in whole or part, such as due to translocation. So these individuals generally have 47 chromosomes 2 n plus 1. Signs and symptoms: although the severity of Down syndrome ranges from mild to severe, most individuals with Down syndrome have widely recognizable physical characteristics. These include alpha flattened face and nose, a short neck, a small mouth, sometimes with a large protruding tongue, small ears, upward slanting eyes that may have small skin folds at the inner corner. The picantic fold and inner corner of the eyes may be rounded instead of pointed. White spots, also known as brush-filled spots, may be present on the colored part of the eye iris. The hands are short and broad, with short fingers, and with a single crease in the palm. Poor muscle tone and loose ligaments are also common. Development and growth is usually delayed, and often average height and developmental milestones are not reached. Down syndrome is named after Doctor Langdo Down, a British physician who in 1866 first described the syndrome as a disorder. Although Dr. Down made some important observations about Down syndrome, he did not correctly identify what causes the disorder. It wasn't until 1959 that Dr. Jerome Lejeune discovered the genetic origin of Down syndrome, causes and risk factors. It is the consequence of autosomal non-disjunction during which 21st chromosome failed to segregate, resulting gamete with 24 chromosomes. Thus gamete fertilizes normal gamete. The new individual will have 47 2n plus 1 chromosomes. The incidence of Down syndrome is estimated 1 for 800 births before the age of 30. Although it is statistically more common with older parents, especially mothers. For example, a woman has a risk of Down syndrome up to about 1 in 3 50 by age of 35. By 40, the risk rises to about 1 in 100. The average of IQ of children with Down syndrome is around 50 compared to normal children with an IQ of 100. A small number have severe to high degree of intellectual disability. Treatment. Although the genetic cause of Down syndrome is known, there is no specific treatment available currently. But it can be managed to some extent by taking few measures like corrective surgery for heart defects, gastrointestinal irregularities, and other health issues is necessary for some individuals. Regular health checkups should be scheduled to screen for other conditions such as visual impairments, ear infections, hearing loss, hypothyroidism, obesity, and other medical conditions. Individuals with Down syndrome should be fully included in family and community life because many children with Down syndrome who have received family support, enrichment therapies, and tutoring have been known to graduate from high school and college and enjoy employment in the workforce. But this is rare case. Klinefelter syndrome. Klinefelter syndrome, also called XXY syndrome, is a condition in which human males have an extra chromosome. Klinefelter syndrome is named after Dr. Henry Klinefelter, who in 1942 first described a group of symptoms found in some men. In 1959, these men with Klinefelter syndrome were discovered to have an extra sex chromosome XXY instead of the usual male sex complement XY. Sign and symptoms. All affected males with the condition do not have the same symptoms or the same degree. As babies, many XXY males have weak muscles and reduced strength. They may sit up, crawl, and walk later than other infants. As XXY males enter puberty, they often don't make as much testosterone as other boys. This can lead to a taller, less muscular body, less facial and body hair, and broader hips than other boys. As teens, XXY males may have larger wrists, weaker bones, and a lower energy level than other boys. They tend to be quiet and shy, meaning they may have more trouble fitting in with other kids. By adulthood, XXY males look similar to males without the condition, although they are often taller. XXY male can have normal sex lives, but they usually make little or no sperm. This is important point. Between 95% and 99% of XXY males are infertile. They may have some kind of trouble using language to express thoughts and needs, problems reading, and trouble processing what they hear. Cause and risk. Klinefelter syndrome is caused by non-disjunction of sex chromosome. During oogenesis in mother, these persons inherit two X chromosomes from mother and a Y chromosome from father. So they have sex chromosome trisomy XXY. Klinefelter syndrome about 1 in 500 to 1000 males. Most variants of the Klinefelter syndrome are much rarer, occurring in 1 in 50,000 or fewer male births. Klinefelter syndrome does not occur in females. Treatment. The XXY chromosome pattern cannot be changed, but there are a variety of ways to treat the symptoms of the XXY condition. Testosterone replacement therapy (TRT) can greatly help XXY males get their testosterone level into normal range to develop more masculine appearance and identity. Having a more normal testosterone level can help develop bigger muscles, deepen the voice, and grow facial and body hair. With treatment, most boys grow up to have normal sex lives, successful careers, and normal social relationships. Educational services and physical, speech, and occupational therapy may also increase their confidence level. Turner syndrome. Turner syndrome is a chromosomal disorder which is characterized by the missing of one X chromosome, 44 plus 1X. In 1938, Henry Turner first described Turner syndrome since these persons do not have Y chromosome, so they always develop as female. Signs and symptoms. More than 95% of adult women with Turner syndrome exhibit short stature. They have non-functioning ovaries, which do not produce sex hormones, estrogen and progesterone, so they do not start menstruation or develop breast without hormone treatment at the age of puberty. Even though many women who have Turner have non-functioning ovaries and are infertile, their other genitalia are totally normal to pregnancy, with donor embryos may be possible. In early childhood, these girls may have frequent middle ear infections. Recurrent infection can lead to hearing loss in some cases. These girls have normal intelligence with good verbal skills and reading skills. Some girls, however, have problems with mathematics, memory skills, and fine finger movements. Cause and risk. Turner syndrome is caused by sex chromosomal non-distinction that may occur during oogenesis in mother. As a result, mother produces an egg lacking X chromosome null When such egg is fertilized by an X chromosome containing sperm, the female baby is developed with 44 autosomes and one X chromosome monosomy. This condition occurs in about 1 in 2500 female births worldwide but as but as much more common among pregnancies that do not survive to term miscarriages and stillbirths. Treatment. Having appropriate medical treatment and support allows a woman with Turner syndrome to lead a normal, healthy, and happy life. Treatment include growth hormone injection are beneficial to increase final adult height by a few inches. Estrogen and progesterone replacement therapy can help in breast development and start of menstruation, which is necessary to keep the womb healthy and also prevent osteoporosis. Key points. All animals and plant cells have nuclei. Nucleus contain chromosomes. Chromosomes are composed of DNA and proteins. The number, shape, and size of chromosome is same for a particular species. DNA is stable molecule and capable of self-replication with full conservation of its specificity. DNA is polynucleotide chain of four different kinds of nucleotide. The difference in type of nucleotide lies in the type of nitrogen bases. Adenine, guanine called purine and cytosine, thymine called pyrimidine. Two strands of double helix molecule of DNA are formed of sugar and phosphate, group bounded in linear sequence and held together by hydrogen bonds between specific kind of bases. Two strands of DNA molecules separate from each other during DNA replication, each serving as a model for synthesis of new complementary strands. Sometimes errors occur in replication resulting in alteration in base sequence along DNA molecule. Change in base sequence results in mutation. Proteins are long polypeptide chains of amino acids. Each gene directs the synthesis of particular polypeptide chain. Three kinds of RNA take part in synthesis of protein, and these are messenger RNA, transfer RNA, and ribosomal RNA. Code lying in chromosomal DNA is transcribed in messenger RNA, which is translated by transfer RNA in ribosome into polypeptide chain. Change at gene level or change in structure or number of chromosomes result in mutation.